Hi, see you again. This time we are going to learn about what is called the piecewise function. So before we learn about piecewise function, you have to make sure you understand about all others function before we come into it, because of this is a function that build from pieces of different function over the different interval. Okay, let us look at this example. We have about 3 different interval here, and from the 3 interval here we have 3 different function as well. So we have to recall back what is the parent graph. So as we know that linear function, then this is a positive x, so basically the graph it should be like this. Okay, going up. Okay, since it's less than 1 and don't have the equal, so later the graph must be with a dance circle and this must be the arrow. Okay, it means you roughly draw the parent graph beside the interval. Okay, after that we look at the second function is the square root x minus 1. So as we know that square root function is the star function greater or equals to 0. So x minus 1 greater or equals to 0 and x should be greater or equals to 1. So coincident, this question given is starting from 1 but ending with 3. So the initial point will be 1 and then ending with a number, cannot be arrow anymore. Ending with 3, so it means when this is a 1 with a dance circle, when that is a 3, it's an empty circle, and the pattern of the graph is a curve. Okay, it's like a curve. And lastly comes to the third one, is a quadratic function. So from here the turning point is 3, 4. And the question given you that 3, 4 is mean it should be open upward. And this is a x equals to 3. Since the question only given you one-sided to the 3, right, because greater or equal, so we are going to delete the left hand side. So you only left the right hand side, then it will be dance circle and going up with the arrow because they given you greater or equals to 3. Next step is we draw the both axes and label with the x and y. And do not forget to label the boundary number from the different interval. So in this case, which is 1 and 3. Okay, so when you look at the graph, it should be ending with the negative infinity up to 1. So it will be when x equals to 1, y is also equals to 1 because you substitute here. Okay, because you are substitute here. X equals to 1, y is equals to 1 with the empty circle. But the straight line must pass through the origin. Okay, it must be a straight line. Maybe it's not perfect here. So you can use the ruler to make sure it must be a straight line. Okay, and then after that, the next one, it will be square root x minus 1. So we need to substitute when x equals to 1. Right, you substitute here, you get 0. So we put a dance circle because equals to 1. And substitute x equals to 3. Okay, when you substitute x equals to 3, so you get that is square root of 2. So it's around here, square root of 2. So you have to label it. It's here, it's an empty circle. And do not forget, it's a curve. Okay, because it's square root function. And the last one is a quadratic, and coincident is given you turning point at 3, 4, and the interval also starting with 3. So when x equals to 3, y is equals to 4. So we label the coordinate y equals to 4 and with the dance circle and going up. So it will be half from it. So you will find that actually its function is not perfect anymore, partially cropped by the interval boundary number. Okay, therefore we call it piecewise function. It's like a puzzle combined together. Okay, so from here, how we're going to determine the domain and range. So for the domain, we will find that the interval that provided is continuous. Why we say continuous? Look at it. 1, 1, and then this with equal sign. 3, 3, and also with the equal sign. So it means that the domain is negative infinity to infinity. Okay, they never stop at any x value. Even though stop for a while, but it will continue by another function. So the domain is a real number. Okay, how about the range? The range we have to base on the graph. So we look at it from the graph. Okay, the minimum y values is represented with the arrow. So this arrow is represent negative infinity. So we follow through the green line is stopping at a 1, y equals to 1. But the next function continue, right? The next function is continue at the square root of 2. So it means negative infinity until square root of 2 with the open bracket because of the empty circle, right? Because of the empty circle. So the square root of 2 is not included. Okay, and then after that, did you notice that after that, the y values in between square root of 2 and 4 without any function or any graph. So it means that you will continue again when the y is equals to 4 because of the dense circle. Then it will be non-stop until infinity. So this is how we determine the range from the graph that we already sketched. So piecewise function, there is no a specific particular domain and range, but it all depends on the different function that combines together. So this is called piecewise function. You can give it a try, 3 to 5 question piecewise function, then you will know about it. That's all for today. See you, bye.